Welcome to Class TV. I am myself, Alibi Tosin. Now let's continue this part 2 of Equilibrium of Forces, and we have discussed and introduced the concept of moments to us. Now this time we are talking about couples. Now what do you call a couple? He said this is a pair of equal and parallel forces acting on a body in opposite direction whose lines of actions do not coincide. Now that is the definition of a couple. We say that a couple is pair of equal and parallel forces. A good example of couples is what do you call it? The water tap. Now let's assume this. If you have a water tap like this, a water tap, now when we want to turn this tap, when we want to lock the tap, what do? We turn it like this. While turning it, this side goes this way and this comes this way. Now we say they are what? Equal forces. The force that is applied like this way, which is the what? The clockwise, is still the same force that is applied here. The same force here, the same force here. So I would say that this is turning this way, this is also turning this way, which means that this end can never meet this end, which shows that they are parallel forces and they are equal forces. And as much as they are equal forces, they are also in opposite direction. This is going this way, while this is coming this way. So we say that this is an example of couples. We say parallel forces acting on a body in opposite direction whose lines of action do not coincide. The line of action does not what? Coincide. Now note that a couple, we said an example of it is a water tap, and also we also have the rotation of a corkscrew. Rotation of a corkscrew is also an example of of a couple. Now that's couple. Now let's talk about torque. Now what is a torque? We said it can be defined as the product of forces and their perpendicular distance between the line of action of the two forces. Is the product of forces and perpendicular distance. Now let's look at something like this. Now this is a circle. This is a circle. This being a circle now, look at it. Let's say this is the center of the circle. A force acting this way, let's call this F1. Another force acting downward. This is a downward force. Right? For this to be at equilibrium, right? This force F1 is equal to this force. I'm not going there. Now, this being the center of the circle, it means that this is the radius. Right? And this is also the If this radius, this side R is also equal to the other side here. R. Now, from the fact that we said that our moment is equal to force times perpendicular distance. Our force, this is our force, right? And the distance here is D, and the D here is 2R. Is 2R because this is 1R, this is another R, is 2R. So you can see that the moment here is is 2FR, where the R is the radius of the circular object. R is the radius of the circular object. Okay, now, so that is for torque. And note, it is also measured in what? A torque is also measured in Newton meter, and it is a vector quantity. A torque is a vector quantity, just the way a moment at the point is also what? A vector quantity. Now, what is the resultant? The resultant of forces acting at a point, we say it is a single force acting along which would produce the same effect as the word combination of the two forces. Now, for that, let's just cite the example. Under our topic vector and scalar quantity, yes, we discuss more on concept of resultant there, so you can just take your, what do you call it, you can just tune to our video, you will see more of that. But let me just cite this as an example. If this is F1 and this force is F2, our resultant force here is this, what is this force R. This is talking about the concept of triangular law of vector, right? Triangular law of vector. Now, also, if you're having this again, and this is parallel to this, so we say that this line here is our what? Is our resultant, because that is the force. This force here is our resultant. It is F1 and this F2, right? So that's that. Now, the resultant of forces depends on the size of the force, and also the size of the angle between the two forces. This one now, the size there is 90 degree, and we have the resultant here. So it depends in a for parallelogram, we say that if this is at the ends of a parallelogram and these are the ends of a parallelogram, then we say the resultant force is this end here. So we discuss more of this on vector and scalar quantity, but the message here is just for us to know that the resultant of force acting at a point is the angle, is the single force acting along which will produce the same effect as the combination of the two forces. We continue on down in our next topic. I do myself, Alewi Tosin. Thank you.